What's up, guys? This is Boo from Mile High Distilling, and today is probably going to end up being a multi-part video just because it's such an extensive topic. We're going to be talking about cuts today, and we're not just going to be talking about your heads, your hearts, your tails. We're going to be talking about that, but there's so much more that goes into those parts. And we're going to be going a little more scientific this route because that's what I love. I love the science, the chemistry of distilling. And I might get a little talky, sure, but I just want to explore a little more into those cuts because, heads, they're not just methanol, which is what some people think. There's acetaldehyde, there's acetone, all that make up those heads. In your tails, it's not just tails, it's esters, it's fusels, it's all these different things that you're creating naturally through a fermentation. And I think it's important just to, look at that info. You don't necessarily need to retain it. It's not going to matter. But I want to talk pretty extensively on cuts because it's a hugely helpful resource to have when you're distilling. So we're going to be going through that all. And before we do, I want to talk a little bit about some keywords you're going to be hearing in this video, and just so you can keep along. Now, one thing we have to talk about is something called esters. And what esters are is when an acid makes contact with an alcohol, they create something called an ester. Acids are naturally found all through your fermentation. They're created in fermentation, could be an acetic acid. There's different things a lot of different things that are created. And then also, obviously, we're creating alcohol. So those two components are bound to touch one another when you're creating fermentation. And so you're always going to have esters present in your distillation. And there's not necessarily anything wrong with esters. Some are good and some are bad. In fact, a lot of esters create great flavor enhancers, and they're actually used in a lot of different foods and stuff. So it's not a bad thing. And another thing we need to look for is a term called fusels. Now, fusels are interesting because if I'm not mistaken, the word literally means bad alcohol. I think it's German. But the thing is the same way with fusels. These fusels create these really terrific flavors in your distillate. Some are compared to bananas, some are compared to pineapples, and those are going to come through in your tails. And again, there's nothing you can do about it. It's something that naturally happens when you're fermenting. So we're not going to worry about it, but we're going to get that info so we have it. Now, I do assume most people watching this video knows what cuts are, but just in case, we'll give you the basic rundown. When you're distilling, you're creating not just ethanol, which is what we like to drink. You're also having a bunch of byproducts that some come up during fermentation, some come up when you're distilling that aren't as good. So for example, methanol. Now, methanol is part of an alcoholic solution. So when you're creating alcohol, there's also always methanol present. Now, of course, when you're distilling, you have ethanol, which is the good alcohol, but you have the methanol, which is bad alcohol, and they're both parts of alcohol, right? So you can't really not get one or take out one. You have to distill it out and separate it out. And how you do that is different boiling points. So methanol, there's a lot of variables to temperatures, but let's say around 155 Fahrenheit. I think 158 is closer for the boiling point of methanol. That means when you hit 158 degrees and you're still, you're going to start boiling off that methanol. Now, ethanol, which is what you want to drink, boils at around 176 Fahrenheit. That means in order to get the ethanol we want, we have to first get to the boiling point of methanol, take it out, have the still continue to rise up in temperature, and then we'll start to hit our boiling point of the ethanol we want to capture. So regardless of what you do in distilling, you always have to make that cut to eliminate the methanol out of the process. So you can't really get around it. And the same is to be said for tails. You don't technically have to distill and get into your tails and make your tail cut. Technically, you could just boil off the ethanol and be done, but you're wasting a lot of good alcohol. And in my opinion, the best flavor of the alcohol you can capture is from your tails because we have all those fusels in there. So I'd recommend still continuing to make your tails cut. And with that all said, before we go into our chart and explain more in extensive detail, let's just explain the very basics of our cuts. We're going to have 4 parts of a cut. That's going to be our foreshots, our heads, our hearts, and our tails. So foreshots are part of heads, but not all foreshots are heads. So your foreshots are the first 250 to 500 milliliters that comes out of the still, and it's probably the worst of the worst. Definitely just pitch all that. Then you're going to get into your heads, and we're going to have mainly methanol there, and just, safe to drink in very, very small quantities, very small. Doesn't taste good, so you don't really have a reason to. Great as a solvent or a cleaner. Then you have your hearts, which obviously you guys want. That's your actual cream of the crop ethanol. Then you have your tails, which are just the tail end of the products, everything coming off at that higher boiling point, like we're going to go on the topic with lots of fusels, lots of esters, different things, and they can be hit or miss. They can be really sweet, really flavorful during the beginning of your tails, and then as you taper off into the very end of your tails, you're going to notice a lot of bitterness, sourness, all safe to drink, and is usually thrown to the next batch to clean up. Now, in just a little bit, I'm going to bring up a chart where we're going to go through each and every one of those boiling points. I didn't even get all of them. There's more than what I've collected, but this is going to get you a good gist of the main components you can expect during different portions of your cuts. So let me explain a little bit about what we're seeing here. Column 1 is going to be the subject, basically the compound or component we're talking about. Now, column 2 is the composition of that component. So you're going to see a theme here. You're going to see in red we have C, which stands for carbon molecules. Green is going to be H, stands for hydrogen, and blue is O, stands for oxygen. So every part of what we're distilling is going to be made up of those 3 components. They're going to be made up of carbon, hydrogen, and oxygen molecules. Now methanol, you're going to see a yellow there that says CH3. That's kind of a strange one. CH is just a bond between a carbon and hydrogen molecule, which basically all of these do have the bonds there. It's just that when you look up methanol, this is what the composition is known as. I'm not versed enough in chemistry to really guess, so I'm going to keep what methanol is known as, which is CH3OH. Now, as far as column 3 goes, it's when to expect these components. You're going to see foreshots, heads, hearts, tails, and a little bit of some confusion, which we'll get into at the end. Now, estimated boiling points is on column 4, and this is uncalculated. So this means, nothing, no variables. Elevation doesn't matter right now. Your water to ethanol ratio in your boiler doesn't matter when it's uncalculated. That's before any of our variables get put into play. Column 5 is going to be with some variables put into play, and that's mainly our elevation here. At Mile High, if you haven't guessed, we're Colorado. We are above sea level, and so our boiling points are going to be lower than what our uncalculated boiling points are. Column 6 is going to have to do with if the component is safe to consume or not. Column 7 is going to be an estimated amount of that component you're going to be finding. And then column 8 is just going to be some notes. I found some, during this process, found some really cool things that each and every one of these things are used for. So let's start with the first thing we should be expecting in our still, and that's acetaldehyde. So these are in the foreshots, and they boil at about 70 degrees Fahrenheit, 68.36 Fahrenheit, that's 20.2 Celsius. So this is before we're really beginning to run and produce or have anything actually to still out, but we're still hitting that boiling point. So that is still going to be present when our distillate finally comes out, because we're much past the boiling point of that acetaldehyde. Luckily, a fair bit of it will get sort of naturally vaporized out as it still begins to heat up. Now at our elevation, we're going to see that 10 degree in Fahrenheit variable because of our higher elevation. Is it safe to consume? No, it is absolutely not. You shouldn't be anyway. It's your Foreshots. You pitch them. You don't do anything else with them. You don't even try. Throw them in your campfire. Do something actually useful with them. But definitely don't consume them. That's dangerous. Now, as far as estimated amount goes, that's a really hard number for me to grab. I mean, I don't have lab equipment. I'm not available to find out these exact numbers. So I'm giving you my best. It's something I can't really measure. So I'm estimating about 50% of your Foreshots are made up of this acetaldehyde. As far as what it's used for, or just general notes, looks like it's usually, from what I researched, used in resin and different things like that. I mean, I believe it's used as a paint additive a little bit as well. It's used in some cleaners and some solvents, which is generally what I would recommend using yours for. The next thing we're going to run into in a distillation process is going to be a little thing known as ethyl formate. So this is pretty close in its composition. We gain a carbon molecule and 2 hydrogen molecules and an oxygen molecule from our acetaldehyde. Now you can also expect this in the Foreshots, but at a much higher degree. We're going from a 68.36 Fahrenheit boiling point in acetaldehyde to a 130 almost Fahrenheit. So it's present much later on, and it's as your stills starts to come up in most cases. So it's going to be present there in the very beginning of your run as you start to boil. Now the boiling point at our elevation doesn't need much more explanation other than what I've given you. You're welcome to read those numbers, but you can guarantee they're going to be about a 10 degree difference. And is it safe to consume? Well, in very small amounts it is, yes. I wouldn't recommend it still. The reason the estimated amount is undefined for me is because if you look at my notes, this is an ester. Now, esters are present everywhere throughout the distillation period. A lot of esters have a much higher boiling point, and so you're not ever going to really boil them through, but they're going to be present everywhere in that liquid volume of what's in that still. It's not going to kill you. It's, some people even consider it a little bit sweet. The next thing we're going to run into is acetone. Everyone really knows acetone, whether you know it or not, because as you're going to see in my notes, it smells like nail polish remover, and that's because a lot of nail polish remover is made with acetone. So composition doesn't change that much. We're actually losing an oxygen molecule. And where you find these is in the end of your Foreshots. So this is a good indication you're getting out of them. You're still going to smell that acetone for a while because you're going into your heads, which have a similar smell. Now, this is pretty close to the boiling point of ethyl formate, so it's just pretty much right around where you start getting to the ethyl formate anyway. And this is also okay in safe amounts, still not recommended. So I recommend, I do estimate about 50% of your Foreshots are acetone, and it's still going to be present into your heads. About 10% is what I would reckon. Now next on the list is one that everyone really knows. This is going to be methanol. So this is going to make up the majority of our heads. I'm estimating about 80%. Now what you'll see here is if you look at the estimated boiling point, you're going to see 148.5. It's about 10 degrees lower than I had said previous in this video. But the thing is that's where I find my methanol, about there. And I've heard that same number, 158, before for other people. And that goes to show you how many variables with temperature there are. I mean, I did pretty extensive research for this video, believe it or not. And a lot of the lab results I'm seeing, that's the boiling point they got. So it's just variables, and I'd recommend, you know what the methanol tastes and smells like. It's nail polish remover, it's acetone. Run a still And when you start smelling and tasting that, take note of that temperature. And you have your landmark. I'm giving you the landmark where your temperature should be around before you start noticing. So just take it all and make your variables that way. Now, the thing with methanol is, if you look at my notes, it is safe to consume in very trace amounts. As little as 10 milliliters to 30 milliliters can make you go blind. That does not take a lot. If you're trying to get those methanol samples and see where you are in your cuts, I'd recommend just taking a spoon, getting a tiny sip. Again, it'll be noticeable. As we proceed along, we're going to start seeing the end of our heads. This is going to be getting into something called ethyl acetate. This again is an ester. So you're going to see during my notes, this is an acetic acid mixed with ethanol. Acetic acid is further down this list in a different boiling point. But even though it boils so high, that's how esters work. They mix in and then they're present all throughout the fermentation and throughout the distillation. So you can see by it, it's changing a little bit in composition, but that 170.8 Fahrenheit. Now, ethanol boils at 173. It's so close to your ethanol that you're only going to get a tiny bit of this before you start heading in to your hearts. So if you look at my estimated amount, we're talking about the last 10% of heads, give or take, maybe even less than that, and then about 3 to 4% of your hearts. And then here we are, right at ethanol, what we want. And this is to mark our heads. So we look at ethanol and we see it has a boiling point of that 173 or so. Is it safe to consume? Hell yeah, it is, dude. An estimated amount is 95%. I mean, it's pure stuff. That's the nice thing about hearts, is it's pretty much just all made up. I mean, you still have those esters floating around in there that are present all throughout, but it's all good, clean stuff. And we proceed along the ethanol distillation for quite a while until we start reaching in a little bit past 200 degrees Fahrenheit, and that's going to be heading into propanol, which is the first part of our tails run. And what you'll notice, and this is kind of the confusing part, is typically you're going to reach your tails before you hit above 200 degrees in the boiler. And again, it's not just about hitting those boiling points. That butanol, everything else in the tails, it's still present throughout the fermentation. You don't necessarily have to hit the boiling point to have it be released, I guess. You're still going to get into your tails below 200, but this is technically when these components of the tails start to boil off. Is butanol safe to consume? Yeah, everything in your tails is. And my numbers start to get a little shaky on estimated amount here because tails are made up of so many different things. It's really hard to dial things in. I'm quoting about 40%, but as far as what butanol is used for, it's used in a lot of medicine. We shoot up another 40 degrees and we're going to start hitting butanol. This is another tail component, and like all tails, it's safe to consume, yeah. Now, again, I'm quoting about 40%. I'm going to guess, from the research I did, propanol and butanol is making up a lot of the sweeter tails. Remember how I talked about the first half of tails is pretty sweet, brings a couple really cool characteristics in, and then the last half just gets bitter, sour. Well, that's where I got these numbers from. Maybe 40%, it's still sweet at that point, things are still going good, and butanol is a fusel, just like a lot of these different things, and they've been described pretty regularly as fruity. They're used in a lot of different foods. And next we have acetic acid, which is going to be used as a point I want to drive home that I've had a little bit trouble articulating. Even though that boiling point is at 244.4 Fahrenheit, acetic acid is found everywhere through your fermentation. It's actually creating that ethyl acetate, which is found way back at 170 degrees right before your heads. I wrote when to expect as mainly head, and that's because, again, we have that higher boiling point, but the acetic acid you will be tasting, or I guess what have you, you can't really taste it. It's going to be found in those heads, right at the end of our heads. So that's when you'll be noticing it, I guess. Is it safe to consume? Well, it's still safe to consume. I mean, it's not really going to hurt you. And throughout, maybe we're expecting about 5%. Acetic acid is used quite a lot in vinegar, so it's safe to consume. Next on the list, we have ethyl butyrate. As when to expect it, again, this is a fusel, and it's just found everywhere through the distillation process because it's created naturally. It does come out about 250 degrees Fahrenheit. Is it safe to consume? Yeah, it definitely is, because guess what, man? It's used in orange juice, dude. I love my ass some orange juice. Throughout, you're maybe expecting about 1% to 2%. I mean, from what I saw, it's really just, there's not a whole lot going on there. Next, we have isobutyl carbonyl, and this one isn't really safe to consume. You can do trace amounts of it. It's still a fusel, but the thing with it is it's so funky and gross, and there's different things in there. It's a carcinogen, which can cause cancer. So it's going to be present. You're going to have a little bit in your distillate. You can't do anything about it. It's also used as a frother to like clean mining, gems and stuff. And as we start nearing the end of our tales and things get bitter and sour, we're going to hit furfural. Kind of sounds like a Pokemon to me. But this is just a really bitter, terrible smell and taste. But the thing is it's safe to consume, and it's also used a lot in cooking. It's used in burgers a lot, different things like that as enhancers. And the last component I felt like was worth mentioning, which is hexyl acetate. This is again in the very end of your tails, but it's going to be present all throughout. It is a fusel. And we're talking now we're in our 350 degrees Fahrenheit almost. Safe to consume in small amounts, but keep in mind what it's really used for is like paint additives and stuff. So, how I try to go off is basically if it's used in food, if it's used in as flavor enhancers and stuff, then I'm not worrying too much. When we start getting into the use as paint additives and resin and stuff, it gets a little bit funky, but again, at this point, your still will probably be shut off. When it starts getting bitter like that, you're going to either stop completely distilling, or you're not even tasting. You're just collecting the alcohol so you can throw it in next batch. And to the 10% of you that watch through all the nerdy shit, I salute you. Thank you. I am going to go ahead and bring this into the next video. We'll be launching part 2 next week. It's already gone way longer than I wanted it to, but I wanted to get those boiling points out there. And during next video, we're going to get a lot more interesting. We're going to talk way more in depth about where those actual cuts are, just the stuff we give a shit about, the methanol and all that. And we're going to talk about, what to expect during those certain parts. I think it's going to be a great video. Thank you guys for watching this one. Sorry if it was a little boring, and we'll see you guys next time.